We are on.
So welcome, good evening, good afternoon, Mickey. I'll call you Mickey. I think that's better. So welcome and good afternoon to you, and good evening to all our audience today. This is our pre-conference keynote. Mickey is a very close friend in the sense we met very recently, but the connect I think goes deep. We had some nice conversations back in Singapore, and Mickey has been doing some amazing work. And today she's here to talk to us about how women bring more power, more flexibility into modern power. Very brief introduction about Mickey. I think her accomplishments are much more than what's written out here. She is a professor of electrical engineering who graduated in 1987 from the Power Engineering Department of UPB. She holds a PhD degree from the same university, and she's been teaching courses on electrical measurements, signal processing, and smart grid topics at both graduate and undergraduate programs. And her research interests encompass synchronized measurements for wide area measurement and control systems, smart metering, DC and hybrid microgrids, power quality, IEEE and IEC standards in power. In fact, she has been one of the technical committee members and working group members for the standards development. And she was a Fulbright's fellow in Arizona State University. She's been the primary investigator of 40 plus research projects funded by both national and international research agencies. And I think it's one of such projects that we kind of connected with the microgrid space as well. Dr. Albu is a senior member of IEEE, and she is a member of WE. So that has an additional connect for all of us. And maybe in her talk, I'll just also read the abstract before I hand it over to you, Mickey. I think we were having a discussion in terms of how we want to present this, and like initially the focus was let's make it, it was more technical, and then suddenly we realized given the audience, the kind of audience, we probably need to make it a little more generic. And since the conference is about women, I think the movement went towards flexibility. So flexibility is a word with ever increasing occurrence in modern times, and work flexibility is reshaping our life. It's also silently connected with the power profile of a household. And Mickey is going to share a lot of insights into that. I think a lot of times, I think women play a very unique role in that we actually observe certain things which otherwise tend to go, neglected or overlooked. Although it's been extensively studied, demand response as a control strategy, I mean, it still has very limited applicability. And I think, especially with the EV coming in and different kinds of energy profiles that we are going to see, I think this is going to have tremendous need to actually understand demand response better. And with flexibility, I think Mickey is planning to talk not just about the power systems, but also what women bring to the table. And that is the reason why I think this is like the perfect start or the perfect pre-conference keynote. So I'll hand it over to you, Mickey, and we are just looking forward to hearing from you.
Thank you very much, Kumudini. Thank you all for attending. I hope that this link to the what women can bring to the power systems in terms of flexibility will be much better, let's say, explained in a kind of together talk. Because it's so dependent on the local situation, the type of household, and we'll see it's not easy to aggregate this information. So as you see, what we have here, it's the formal title. As usually I'm presenting the contribution of measurements and what changed the measurement in the measurement world for active distribution grids. we will explain immediately what does it mean. The contribution of women to this new world, it might sound as a buzzword, flexibility into the power systems, but has really dramatical consequences, and we'll speak together about. My presentation will look first to these new things that appeared into the power systems from every end user point of view. Some of these new things are here again highlighted as energy communities and low inertia systems. We see this. And the answer is, at least today, is flexibility, and what brings flexibility into this into this game changer, which is the way the systems is planned and operated. And flexibility, of course, we can quantify only when we have some good models. Doesn't matter if it's an electrical model or behavioral model. So we need measurements, and when we speak about measurements, then we collate with the world of ICT, which is so predominant today, that is using data and forgets about information. And so measurements are this this bridge, make this bridge between information and data, and not to forget that actually what we need is good information. So the overarching, let's say, topic of the talk, I hope, that is knowledge, which brings power to control the power, and not to control the energy. We'll see immediately that is what changed today in the power systems. So, but before going to this power talk, I'll speak a little bit on myself. I am the daughter of two power engineers. My father was working in one of the largest power plants in the country at the time. My mother, although power engineer, she was teaching in a power engineering high school. My sister is still working for one large power company, so it was natural to arrive at the power engineering faculty in Polytechnic University of Bucharest, where I graduated from. I did not write here. It was very easy for me because when I was a child, so until I was maybe 25 years old, we did not have a free Saturday, we did not have a free Sunday, and I was, let's say, taken since I was 3-4 years old to be together with my father in the power plant. So I knew, how to play with and recognize things since I was a child. But then, as you see, it took me more than 10 years to finalize the PhD studies, because we had to work in parallel to perform teaching in university and research for surviving, and in parallel to do the PhD work. I did not mention that in parallel I was raising my daughter. And then became a professor and group leader. I would not mention this micro lab, the group, if would not be, let's say, we'll see immediately, that would be something that at least in my university only a woman could have done, which means to put together groups from different competing faculties. No one was able to do something like this. And then work for the Instrumentation Measurement Society, including in the IEEE, including the Administrative Committee, or distinguished lecturer, so travels abroad, and contributor to standards, not only IEEE, but also IEC. Today, I'm working also for some national committees for research, like the Research Council. but this actually shows a lot of work that is most of the time silent. It's only work without recognition, without any type of rewarding, except the happiness that you did a good work or not. I mean, if you do a good work. And this is very much related to the position of women, at least in my country. But I think that in engineering and teaching, this is the position of, in many places where it's no problem to have allocated a lot of work, but not the positions with recognition. So if you wonder where is Romania, this is the globe. It's in eastern part of Europe. And if you wonder about the economical status of Romania, this week was published the Eurostat data with a list of European countries by economic growth in these 22 years that actually overlap with my main activity in the Polytechnic University of Bucharest. And from the Eurostat, it turns out that the highest economic growth rate in Europe was in Romania. It's 800%, by the way. So just to understand the time frame where I was going from the student years to research, and also to understand something about Romania. Again, here is the Romanian map and some facts. Maybe most important, we are about 20 million people, member of European Union since 2007. But if we want to connect with the power engineering, so slowly going to our field, maybe it is not well known that still the largest onshore wind farm in Europe is in Romania. It's in this Fântânele Cojalac position in eastern part of Romania with about 600 megawatt. Of course, there are larger wind farms, but those are offshore in Europe. We have a lot of PV plants, not that much, so we have less than 2 gigawatt, but we continue to invest in renewable-based electricity generation. Maybe more interesting if you have ever the chance to visit Romania, so about 100 kilometers north of Bucharest, there is still in operation a hydropower plant after 133 years because it was commissioned in 1889 and is still in, as I said, in operation. Bucharest was the first city in the world illuminated with kerosene lamps. Okay, this is not related with electricity, but Timișoara, another Romanian city in the western part, is the first city in Europe illuminated with electricity. Also more than 100, almost 140 years ago. The university where I'm graduated from and I'm teaching is also about 200 years old, and today has more than 30,000 students in 15 faculties, but all in engineering and mostly electrical engineering, which means electrical, electronic, automation and control, power systems, transport, also some mechanical engineering. And here is the some views of the nice park. Actually, is just to my left. I'm in the office now, and we can look to some figures related to the girls and women part of this academic community. Just to let you know that when I was a student in the power engineering faculty, we were 70% girls. And this was related to some economical and political constraints where we had to accept a nationwide distribution of jobs after we finished the university, and it was not possible to deny. So it was, these jobs were given in the order of final the rank of final marks in the faculty, and all cities that were forbidden in general for the students, but industry and especially power industry was located near the cities. So this is why the girls prefer to be engineers, to have a working place near a city, which was with much more, with better conditions than being in the countryside, as graduating, for instance, literature studies. So what I want to say is that this type of constraints disappear. So these are not anymore for the 30 years. So the relation of girls with the power engineering faculty or engineering in general faculty is completely different, is based on true understanding of the work that they will have to do. So I said that 20 years ago, I managed to build a group, a research group, with members from 3 different faculties. Now I am with electrical engineering. There are also automation and control and computing science and power engineering. And I'm very proud that I managed to do this, as I said, between competing groups. However, there are very few girls, women in this group, which is not at all a good achievement. Reasons, yeah, we can analyze them immediately. Here are some research projects that we were recently pursued, and you see all are in terms of storage, which is a flexibility option in power systems, measurements, and so on. But the closest to my heart project is this Marie Sklodowska-Curie project, this in Extiv, where to Dr. Irina Ciornei, fellow, woman fellow, was awarded this fellowship, and she studied power quality in DC microgrids. And why is it so close? Also because Irina was the first recipient, the first fellow to a Romanian university. Oh, I'm sorry. Sorry. And this was for our group was fantastic to have someone from outside. She is not from Romania, to be awarded in such a competitive competition, competitive call, this fellowship. Now about IEEE Romania. We are about 900 members in this section, and mostly focusing on computing and electricity and power. We see these first 2 percentage information, and about 21% are female members, which is a good number, but not as good as it was before. By the way, in Romania, there are about 560,000 scientists and engineers, and 41% are women. Exactly the percentage in the European Union. I mean, as an average in the European Union, you see that is varying this percentage from Hungary and Finland, 29%, towards Lithuania, which is the highest percentage, almost 60%. However, and this is maybe important, if we see If we see the European Gender Equality Index, Romania is not very high, 25th place, and globally is even worse, 50%, which we might translate into the fact that we have scientists, we have engineers. Yeah, it's the aim of population women is towards science and engineering. 41% is a high percentage. However, the conditions in terms of gender gap and gender equality are not that good. And why? Because it's somehow traditional in the rural areas, girls are still advised towards soft careers like economic studies, psychology, foreign languages, teaching, um, and not, or even household occupation, yeah, not studying, let's say, hard uh, studies like engineering. Uh, but there is also a paradox, and this is linked to what I said before. There are a lot of women in research coordination as principal investigator or even leadership positions, but all related to hard work. So it seems that which are not, let's say, these positions are not rewarded with some monetary or other type of recognition. Yeah. What we saw here, it's a recent project we just we finished in the spring, Engineer Your Future, where we were sponsored especially by the US Embassy in Romania to promote among young generation, the youngest in Romania, to promote engineering studies, especially electrical engineering studies, and especially towards girls in all over the country. And we see this problem also if we look to the number of PhD women PhD students, which percentage-wise is much lower than the number of women which who graduated or master or undergraduate studies, and only one good news we can see that not like in other countries. In Romania, almost 26, almost 27% of the total number of employees in the ICT, yeah, communication, information communication industries. So more than 26% are women, compared with an European average of only 17%. So these are the good news. If we move to the electrical engineering faculty, where I'm now, we can see that from the total students, 21% are female, a little bit more, 25% in the direction of management of the faculty, engineering and management. And for the master studies, 20%. So the percentage is decreasing for the masters. So already it's decreasing. And this is worrying us because it's decreasing over the years. For instance, in 2003, we had about 26% graduates, female, while today we reach about 21% graduates. With the teaching staff, it's been even worse. We have 33%, which might look well as teaching staff, so lecturers, senior lecturers, and so on in the faculty. But PhD coordinators are only 12%, so only 5 female. In Romania, PhD coordination is awarded after a exam and with a lot of conditions. It's habilitation like in Germany. So doesn't matter if you are a full professor, you have to pass a separate exam, habilitation, in order to become a PhD coordinator. And you see this step is reached only by a few colleagues. So this is about setting up the scene where I'm speaking of, and now we'll move a little bit on the what is new in power systems today. And I will not insist in many details, just to observe that we decided worldwide, yeah, the population decided that we need to decrease the greenhouse gas emissions. And immediately, or let's say very soon, the solutions at bulk generation at high voltage, the so-called transmission system, with large wind parks, with hydro large power plants, with large installations of PV, like here and here. Soon this was exhausted, and in order to decrease more the greenhouse gas emissions, the only possibility appeared to be to harvest the energy, which means low quantities, and this means connection at low voltages, as close as possible to the consumption. And this is what we call distributed energy resources that we want to increase as much as possible. And so we ended up with this solution of generating small quantities of energy as close as possible to the consumption, which means at low and medium voltage, so at the distribution level, which also might not be as dramatic as it appears now, but in order to take this electricity or this energy, let's say, to use this energy, we needed power converters, static power converters, which means that the available inertia in the grid is lower because power converters have zero inertia, so it's nothing rotating and moving, which means that the control needs lower time constants if the inertia is so low. And in order to perform this real-time control, we will need, as said, other solutions. And we need also models to discriminate between steady state and dynamic situations. And now what we were prepared, all of us in the power engineering community, we were prepared to look to the generation side, but we were never prepared to look to the consumption side with real time, low time, this time constants, lower, achieving real time control. And this means that one major change is that we had to move from this energy control, like looking to the bill every month, electricity bill every month, towards power control, which means looking to what happens into our micro system every second or every sub-second. So this is the major change, looking to the power control. And then the next step was to observe that we need to provide control. We need a mean of flexibility, and if the generation is inflexible because it's more and more based on renewables which are unpredictable and intermittent, then we need some other ways of providing flexibility. What means 2Q, two quadrant, which means either generation or consumption in the same place, because we remember we wanted to have this generation in the place of, or as close as possible to the consumption. This is a new paradigm of functioning of local grids, and economically we speak about energy communities sharing resources either in terms of consumption or in generation, and the infrastructure of these economical terms business as communities would be microgrids. So this is why I was mentioning this microgrid, and also just for your information to understand that this is quite a new topic. If we look to the publications in IEEE Explore having microgrid in the title, we see almost nothing in 2000, yeah, and then increasing exponential to 2000 to the present times. These tiny blue dots represent within these publications those who speak about model and measurements. As you see, very few, so it's a lot of work to be done. Now, I think that we understood that we have to look to make the control on site and to manage somehow to keep the constraints in various forms, those constraints. Maybe the constraints to the exchange with, to exchange electricity with the distribution grid, while we have a lot of unknown situations. And this unknown is the local generation. And what we have here and also here is a snapshot of one day PV generation right here on top of the lab in university. It's far away from that nice curve that we learned that is increasing when the sun rises and then decreasing just because of the clouds, which are also unpredictable. And then we have to manage the electricity with various profiles of consumption. And therefore, first of all, we have to do it very fast because it's lower inertia. And then we have to estimate from real-time measurements the load flexibility to operate, but also we have to think how much we need to invest in the future. So we need this estimation also for planning. And until recently, the answer of the power engineering community to this fact that we cannot control the generation was okay, we will control the consumption, but in a kind of on-off, very brutal, controlling in this expression or strategy that we call demand response. And if you look how many times demand response appears in the title of the papers in IEEE Explore, until now there are about 18,000 entries. And can you imagine that this has to change because now we speak about more intelligent response to this variability, and this is with flexibility. So if we look to the keyword flexibility, don't be afraid. I will not read what is here, just to give you a little bit of information that there were about 20 papers until 1990. They spoke about heat recovery, some papers on storage. Then in 1990, a few papers spoke about market flexibility. And then again, more papers, so decades. And we have here the increase topic, presence of the topic in IEEE publications with flexibility on energy. These are only for the past 3 years, 2020, 21, 22. Don't be afraid that our last papers 2022 is not finished. We still have time. You see that there are some key messages related to how to cope with or what the end users have to do. And don't forget that end users in a household at low voltage have more knowledge on how to answer to the to the constraints around to the constraints with the distribution system companies. So these users are mostly mostly knowledgeable are the women. So they have to be asked if it's true or not with the ideal demand system that works without with the shifting of the consumption, which by the way is not not the right answer, yeah? Or what is the user comfort, thermal or not, because it's not only heating that is required for the electricity use. They have to be asked mostly when some in my mind, stupid examples are given for flexibility in the sense, well, switch the washing machine in the night because then is low consumption that we want to flat the consumption curve, which is not possible. Oh, I'm sorry, it was my timer. So I'll speak very fast now. So we know that you cannot put the washing machine in the night because it makes also noise. And so on. So here are a lot of highlights from what flexibility was considered from the users in buildings mostly, and how we have to go towards new solutions, and they are usually in the sense of user response behavior model that has to be established, and or investments in batteries, or as I just heard that it's a lot of work towards electric vehicles, especially the solution with the vehicle to grid. How can we use this to modulate the profile, the power profile, without affecting yeah, the rest of energy use? How can we do this with devices, measurement devices like smart meters, which today are unfortunately designed as to give only energy information and billing information instead of giving real useful power, and what we expect to know. And here are examples of um, recording of the power profile at an apartment in Bucharest in May, 15th of May 2020, the same apartment of 27th of May in the same year. And you see recording with 1 second resolution is the blue line. And if we would have look as information one per day, would have been just one tiny line about 100 watt, while the power profile is completely different. By the way, these peaks are the moments when the refrigerator starts, and it's of no importance if it starts now or 10 minutes later. Here, it was so unfortunate that the fridge started together, or I mean, in the same time when it was also the washing machine, different type of programs. What what is important here to see is that if we decide to close our eyes and look to the averages as provided theoretically every 10 minutes, but theoretically because mostly the information is given only once per hour as an average, we lose about 140% of the information in this case, or more than 100 in the second case. And if we think that the fast answer, well, I don't care about one single user. Let's look to the community and the consumption of each household in the community will somehow cancel. Well, we are not in the 20th century, we are in the 21st century, where this theory is not working anymore. And as an example, we have here to the right, we have records every 2 seconds this time of the power profile on each level of a student house. Every level, yeah, has about 100 students. Uh, so with the same profile in the way, they are all students, yeah, studying in the same university. And still, in one day, if we look, the power profiles are completely different on each level. And this happens, yeah, if you are curious, here is some interesting cryptocurrency digging, we suppose. So this means that aggregation in space, yeah, connecting more, is not solving the issue. So this is why we have to derive models in order to meet some requirements. And these requirements can be met when you have something unpredictable and uncontrollable, either putting a lot of money, which means storage. Here is an example of such a small community with two participants, or to put a lot of intelligence in modulating the power profile at the consumption side in such a way that no one is suffering, but also you meet the constraints. Here are some examples. This is not not important of simulation, and here are the student houses where we put those smart meters and examples of uh, consumption, yeah, in one day with one floor. So here is one floor, and how we can lose information if we look only once per hour. And here it's another floor, a completely different power profile that has to be studied. If we look a little bit in more detail, how to predict this type of consumption, imagine that this is one day and we have 365 days in a year to plan and operate. Then there are some techniques based on matrix profile technology, for instance, where we can identify, but we cannot with looking to the time to the power profile, we can identify the most dissimilar situations, and they are called the scores, and most similar situations, which means at what hour every day is more similar the power profile, and so on, which is a very nice technique, which, but in order to be used, we need context, more context information, and this is to be provided only by those end users. Yeah, it's not. It's a nonsense to look to discover discourse only and motives only with analyzing large sets of data. With this, I will conclude with an image from a small community that we are studying near Bucharest, and we try to look to the how to manage the power profiles in direct communication with the end users, yeah, that are living in that community, and to understand where is the limit of flexibility, how can we reach, how can we program the order of appliances, and how is the minimal investment in storage in order to save money and quantify the flexibility. So I conclude here. Hope that we made a kind of survey of what means emerging power systems, that is the need of flexibility, and how can we play with accurate, or how can we obtain accurate models from data analytics. And again, the context is essential for deriving this type of accurate models. Thank you, and I hope that we can speak in a question and answer session freely. Thank you.
Thank you, Miki. And I think we'll ask the participants to ask questions. But maybe I'll start it off so that we can have this going while the students put their questions in chat and the participants as well. You were talking about, this entire power profile and how, there are these sudden instantaneous bursts of power. What does it mean to the system itself, and why are these measurements so critical? Because we are investing in larger and larger systems just because we think we need to manage these huge, rises in power and so on. But are we really looking at the right picture?
Yeah, thank you for the question. I think that we invest in large power systems, but we invest with the aim of having renewables introduced. And in most of the situation, most of the countries, this use of renewables is already exhausted at large power. I'm sorry, I think it's here. So we speak now about investments in near households at low power. And at low power, we saw that PV, if we speak about PV, is very much fluctuating every second. And we would like to compensate this fluctuation with the controlled fluctuations of the consumption. And we have to think which is the goal, because you said if it is an impact. It's not, there are several impacts, but let's think to one very simple. Suppose that we generate now electricity with PV, it's sunshine, and we don't consume anything. And this doesn't matter, it's 1 minute to several seconds. This electricity is going to the distribution grid. Anywhere it's going will cause losses because it's traveling, the current and supporting the electricity transfer is traveling. We don't care if it's traveling 1 kilometer or 2 kilometers of the lines, it's traveling, causing losses. And after 10 minutes, we don't have PV because it's a cloud or it's already night, and we consume electricity. This is also traveling, causing losses. So the idea is that if we generate locally, it's better to consume locally, because otherwise we'll cause unnecessary losses. And this is one very easy explanation. But there is also another explanation that when you generate in nodes where before you had no generation, it might happen that the voltage is rising. So quality of the electricity is not as it was supposed to be. And you have to counter, to have a solution for that. And the only solution is, again, to have generation and consumption in a specific equilibrium in order to avoid further losses or further investments. How to do this? If you cannot control the generation, the only option is control the use of electricity. And this is the issue, that we need information, and we cannot, because generation is fluctuating so fast. The use of electricity today is fluctuating so fast. This is what we have at home: appliances. We have chargers of of computer, we have chargers of the telephone, we have electronic lamps, we have all these intelligent washing machines. Everything is with high variability of the power and complicates.
Thank you so much. I think we have one question from Anish. Can you see that, or should I read it out?
Now I try to access my my WebEx page, but it's very difficult to access it.
Okay, I'll read out the question then.
Please.
So he asks, stability of power systems is a critical need for any utility. Today's context of adding more and more renewable energy and electric vehicles to modern power systems, what would be the impact on stability and how can we tackle it?
Well, stability indeed might be impacted, but at high power, high levels of power. So in that, what I was showing, that transmission system operator, it's so if we move to this level with high power generation from intermittent sources, then indeed might be a problem of stability. First of all, because we have all our control set with larger time constants, about 3 seconds for let's say a system like Romanian size, and we have to move towards much lower time constants, which means that we have to react much faster. And in order to react much faster, we have to measure much faster. And then we go into even philosophical problems because we don't know how to define what we measure very fast. Like rate of change of frequency, we have first to define it, and it's not yet defined. The practical solution, as always, is with money, which means with investments in storage. So today, the solution for this type of events or avoiding instabilities is to have access to storage, fast access. But fast access to storage means storage plus converters. And converters, not to forget, at zero inertia. So it's like we answer to the problem, but we increase this this issue of lower time constants. I hope that I answered it.
Yes, thank you. There's another question which is from Professor Deepa. She asks, are there any cases where the measuring devices have malfunctioned and that has led to a fault?
Well, measurement devices are supposed to give the information, not to malfunction. But it's a it's a very nice question. Actually, is what we are working now hard on is the fact that we use the measurement device inappropriately. To be short, if we measure, let's say, if we measure the frequency, the measurement device is supposed to measure and report an average of the measurement over 200 milliseconds. And this was good enough when we had enough inertia. So does not change much in 200 milliseconds. I'm speaking about measurements, not projection. Yeah. But today, because we have this low inertia, the poor measurement device, the frequency meter, is giving us an average, but the average is made on very different values. So in a way, does not give us any information. The truth is somewhere else because each value of the frequency, 200 milliseconds, we have 10 values. Each value is very different and is giving us the average because we planned it to do this. So it's our fault that we planned to look to the averages, so larger time constants. So what we have to do is to change this, to plan from the very beginning for the measurement device to give us as close to the truth the information. I think it was a now I see the the chat. Well, I know, but it was not in our case. It was not a measurement. It was a protection based on rate of change of frequency. And this example was invoked in several papers, maybe 2 or 3 years ago in the IEEE Instrumentation and Measurement magazine and then transaction. The idea is that if we define wrongly a quantity, then we might have surprises. And this quantity is rate of change of frequency. If it is defined as derivative of the phase angle, second derivative of the phase angle, then in case of faults with phase jump, so special faults, the value is unnecessarily high and can lead to decisions, to bad decisions. But not it's protection, not measurement.
Did you see the next question?
Yeah, with the delay in the information at the protection. Actually, this is really a huge problem because all protections are set for time constants, larger time constants. And now, because we have lower inertia, in Romania, not yet that lower inertia, because we still have a lot of classical generation with rotating machines. But if the inertia is lower, so the protection has to be set with lower time constants, and you have to run a lot of studies on that. And instead of answering directly with better protection systems, the community, the power engineering community, started to look how to emulate inertia. So to add virtual inertia, so that to leave the protection systems as they were and fake the lower inertia into a larger inertia. And these are very interesting examples. I don't know if artificial intelligence or machine learning can help in this case. I think that the key is again in measurements. And as we see, the digital substations are emerging now in terms of using a completely different approach, which is sample data approach. What does it mean? And the standard is already approved maybe 2-3 years ago. We have the waveform, voltage or current. We digitize it, and then we send the values, the samples, and with those samples, we can make as an algorithm a distance protection and overcurrent protection. We can have measurements. We can have a lot of things. So it's another approach, but I did not see yet functioning digital substations. I know they are already in place, but I did not see personally.
We have one more question from Deepa. She is asking, what's your stand on moving to DC grids from AC grids, and is it feasible?
Well, as a promoter for almost 20 years of DC grid, I would say yes, it's feasible. um, what stopped us, at least at low voltage, because we know DC high voltage lines we have for a long time, and this is not an issue. The issue is at low voltage. So for appliances, for normal end user at low voltage, that has PV at DC, that has storage at DC, that has all appliances today, maybe, yeah, maybe 90% of them, they work at native DC. I mean, computer and everything, like illumination, yeah, smart lamps. Um, so it's obvious that we have to move to have everything to DC. What stops? First of all, the lack of standardization. It's only recently that a kind of attempt of standardization of DC voltage levels is occurring, and I'm happy to say that there is a working group on IEC on DC microgrids, and is very productive. So standardization is lacking, and secondly is lacking the power over the appliances world, producers world, to say, guys, it's time to give us the plug at DC and not at AC, and switch off this power supply, which now is at AC unnecessarily. But this power, it we lack. The power engineering community lacks this power over the appliances community. I think this is what we lack, still lack now.
Another question.
I see the last. I see the last comment. Of course, this is rethinking, and I attended also some conferences at European level. I mean, decision level, European wide, and it seems that it's more than clear that in the near future we'll have only one large transmission system where we inject power from maybe large nuclear power plants, or I don't know what other large nuclear power plants, and the rest will be a collection of microgrids which will be able to work independent, and only in case of faults can help each other. So let's say like this. But indeed, decentralization would be the word. But again, I think that we face some decisions at regulatory level, legislation. It's here is the difficult part. It's not like in communication where we exploited for the past 30 years a lot of regulation, and so it was so well developed.
With the advent of the communications itself and most of the power system management happening, with communication integrated, I think today the possibility is higher, right? In terms of even managing our distributed energy systems, our managing microgrids. Microgrid is such a beautiful alternative, right? But people still don't seem to see the value of it.
Maybe they see the value of it, but they consciously delay this development. As we used to say, at least in Europe, the large power companies, I mean transmission system operator, they are really too big. They have a lot of power, but this is another another talk. The barriers are usually from the laws in each country and the regulatory barriers. Yeah, that can be changed by people. by women.
I think Ashwini is asking a question. Do you want to
No,
unmute?
that was a private comment. So I just felt that capitalists at play here again. We should be probably democratizing things. Well, I don't think that would be possible, though.
I did not get it. I'm sorry. Could you repeat? It was a comment, but I could. Please.
Hello. Yeah. So it was the same thing that Kumudini was talking about. So I was just wondering if it's more to do with the capitalists, trying to jack their cards up.
No, I don't think so. Um, it's about the fact that electricity and the energy systems were developing, considering that electricity is a common good and have to reach everywhere, at least in Europe, in Americas. And if we want to deviate from this and work on local distribution and local use, it's possible, but needs investment. And the problem is who is going to pay? I think that in the end, this is what is giving us the delay. Who is going to pay? Because, for example, even today, if we encourage the PV use, yeah, I have a neighbor that it's putting PV on and it's very nice, is generating locally. But while it's putting PV, will make raise of the voltage on the feeder, and in order to keep the voltage, because this is how the system was designed. I have to keep the voltage within some limits, because otherwise, what I'm buying as appliances and everything I as end user will not work properly. So the whole world is functioning based on some assumptions. And in order to keep the voltage, because my neighbor is generating PV and I'm really happy because it's much cleaner the air, we have to invest into larger transformer or larger cables. Who is paying for the larger transformer that is keeping the voltage in the frame? Yeah, because my neighbor was putting the PV. It's me and the others who have no PV. So it's such a difficult problem of allocation of costs that is delaying. So until we will have a democratic solution, but it's very difficult to have it, we will still use the old system. Yeah, the old system of sinking, let's say, and distribution of the electricity.
So thank you so much, Miki. And here is a virtual plaque. So thank you so much. And it's really interesting to listen to you. And I hope our students also benefited from it. Many of them are, in their final year of engineering, and they are actually deciding on their projects and so on. And I'm hoping that a few of them can consider this as a potential project or research that they want to take up in the future. So thanks a lot. And yeah, any last words you want to share, or
Thank you all very much, and I do hope that you'll think, yeah, in the future to the electricity use, and I also hope that you will be part of a novel system, because this will come. I don't know if in 5 years or 10 years we'll have indeed these more distribution grids, microgrids based energy communities, and will be great that in your points of decision, where I'm wishing that you all will be, will apply, yeah, this with courage, yeah, these new trends and implement without the fear that we had to be like in the past. Thank you.
Thank you so much. And I now request all the participants to kindly switch on their cameras. Maybe we'll have a quick, capture of this moment, and then we can end for the day. I request all of you to kindly start your videos.
Yeah, it's a lot of bandwidth that we occupy now.
Thank you so much. Thank you so much again, Nikki.
Thank you.
And I hope you visit India soon.
I'm
Sure,
really
madam.
looking forward. Bye.
Bye.
Yeah, thank you. Bye. Have a good day, all of you.